My name is Bill Bailey, and I'm a mechanical engineer working in the applications group, Proton Energy Systems. And Proton is a hydrogen generator manufacturer. And what I'd like to do today is talk a little bit about Proton's background, our technology, and then touch on the systems we make for the power industry related to that, and some of the economics associated with it, on-site hydrogen generation. Proton Energy Systems is located in Wallingford, Connecticut, up in the northeast. We're halfway between Boston and New York City. We have a 100,000 square foot manufacturing facility there. It was built about 5 years ago. And you can see we're a state-of-the-art production facility, quite clean, obviously, for hydrogen generation manufacturing. And we are, of course, ISO 9000 registered, and continue to produce systems that ship around the world. We have systems, everything from a desktop computer that's used in the analytical markets to a mid-sized generator that unfortunately looks a lot like a dishwasher, and to a larger system typical for a power plant application. You see here, looks like a large telecom cabinet. And those systems, again, are shipped around the world. We can count systems on all 7 continents, literally. 2 of our mid-sized generators are located in Antarctica, where they use hydrogen to fill weather balloons. So obviously getting cylinders down there is a bit of a challenge in Antarctica, so we have a couple of our systems down there to fill weather balloons. So I'd like to just touch on the standard supply modes that you're probably very familiar with as far as hydrogen goes. We've got cylinders, standard cylinder storage that you see, in standard cylinder delivery, either with 4-truck or in 6-packs, or in some odd cases individual cylinder delivery. And of course you have either tube trailers or high pressure storage that you might have at some of your sites around the country. The modes of transportation here are well known and have been around for many years, but we propose that on-site generation is a much safer and more practical approach in the long term. You've heard incidents around the country and even around the world about incidents taking place with hydrogen delivery. So we would propose that on-site generation gets rid of a lot of those potential risks. Delivery in itself has some inherent risks. You're transporting thousands and thousands of cubic feet of gas into your facility at very high pressure, and then you're making and breaking connections on a regular basis, sometimes twice a month, sometimes more frequently. So we recommend on-site generation can relieve a lot of those safety risks and provide a better solution. The traditional methods are affected by commodity prices like natural gas. Granted, natural gas is lower at this point, but I'm sure with all costs that will continue to rise. Diesel costs are the largest part of the delivered price of hydrogen. So those large tube trailers that you occasionally see on the road, you'll see in your plants, those are all delivered by diesel tractors, and those come from can be long distances from the original generation site. And of course, because of those items, the price can be highly volatile depending on the market at the time and what's happening in the world. During the Katrina hurricane, or just after the Katrina hurricane in Louisiana, we experienced an uptick in activity within our business, because at the time, the hydrogen generation plant, one of the major generation plants in Canada, was down for expected maintenance. Katrina came through and took out generation of hydrogen in the Louisiana area, and then the other major generation site was in California. So because the 2 were down at the same time, a lot of people started getting the call, you're not going to get hydrogen. So industrial customers, semiconductor, heat treaters, those type folks started to get calls from their suppliers saying, we're not going to be able to supply hydrogen to you. Be prepared. And occasionally we've heard the case of even the power industry getting a call that we might be short in those extreme cases. Delivery logistics are intensive, both for the supplier and for the customer. You need to keep track of inventory, certainly in an individual cylinder or cylinder pack mode. You need to keep track of those cylinders, move them around your plant, most likely for safety purposes, and of course billing and ordering is also a concern. And of course safely managing delivery and changeouts is important. From a safety standpoint and just energy standpoint, looking at hydrogen in the current delivery mode. Common tube trailer, 20-footer, is approximately 50,000 cubic feet of hydrogen at 2,400 psi, typically. So equivalently, that's about 5,500 pounds of TNT you could have sitting at a location. The larger tube trailers you might be familiar with, the standard 40-footers, twice that amount, so 100,000 cubic feet, 10 tons of 100,000 cubic feet of hydrogen, 10 tons of TNT potential. 12-pack portable cylinders, which are very, very common. 3,600 standard cubic feet of hydrogen there. Again, 2,400 psi, 420 pounds equivalent TNT there as a reference. So alternative is on-site generation. You can see from these two pictures, on-site generation is very compact, and the generators are sized to meet your daily makeup needs with a little excess, depending on how you want to configure a hydrogen solution for a plant. This small generator, this is the generator I spoke about that unfortunately looks like a dishwasher. That'll put out 40 standard cubic feet an hour. And a larger generator here, which is configurable from in three production rates, the maximum of 228 standard cubic feet an hour. So on for a 24-hour period, this unit could produce close to 6,000 cubic feet if needed. Of course, the generators are all NFPA approved, they're all UL certified, they're all CSA certified, and they're all CE certified as well. So shipments around the world are standard for us, and certainly common here in the US. And the beautiful part about an on-site hydrogen generator is they're designed specifically so that they don't classify an area hazardous when you install it. So literally, you could install a hydrogen generator right here in this room. You do a check of the ventilation exchange rates within the room, and then you can install your hydrogen generator as long as you're within those limits and not classify the space. The mid-sized generator here you see here is typically used, again, in the metrological application or in the large analytical applications like refineries, where they have large analytical labs. And those generators are placed right in the analytical lab, right next to existing benches and analytical equipment. So, the alternative approach, the price is directly tied to the plant generation rate costs. The nice fit about on-site generation for the power industry is that it uses the same utilities you already have on your sites. We electrolyze water, we split water into hydrogen and oxygen. You already have demineralized water in your facilities, so you just run a line over to it. You already have hydrogen infrastructure to handle the hydrogen. Just plumb the hydrogen generator right into your existing infrastructure. And we use electricity. You already make electricity, and you're making electricity at the least cost of anyone. So your cost to generate hydrogen is quite low. You're in the fractions of a dollar to generate 100 cubic feet of hydrogen versus delivery prices of $5, $6, $10 per 100 cubic feet. And of course, the nice thing is your hydrogen price remains fixed. If you charge yourself for the electricity used to generate hydrogen, if your price of fuel goes up slightly, then your generation price goes up, but it's still going to be much cheaper than delivered. And when you factor in considerations for safety and whatnot, you're still way ahead of the game as far as delivered solution. The integrated solutions are such that the hydrogen generator is a complete package. It has power rectification, it has onboard water monitoring, it has power onboard control systems, and has the capability to generate hydrogen up to 200 psi, or the larger systems can go up to 400 psi if needed, depending on your application. Well, that's in a complete self-contained box. So we bring in water, we bring in electricity, and we produce hydrogen at 5/9 purity and a dew point of below 5 parts per million water content. The systems are fully automatic, such that once it's installed and connected, it's a push-button start. The system goes through its normal onboard system checks, sensor checks, starts up, brings the system up to pressure, and and then monitors the discharge pressure